Hello, folks. Let's get going. So, what do you want to talk about? We were able to accomplish last week.
I haven't got very far this week. I spent the entire week trying to fine-tune llama models, which I eventually got one fine-tuned, but I'm not really sure what I'm fine-tuning it for. On the internet, there's like a load of tutorials about how to fine-tune like a llama model, but none of them actually sort of show you sort of what you would get before you fine tune it and how you would like do the inference after you fine tune it. So
yeah, in fact, that's a very interesting comment you made, because I have been, I looked at the notebooks that Raquel pointed to, and that confused me a little bit, because in terms of getting the terminology correct, even of what is fine tuning versus what is RAG, which is retrieval augmented generation. And I think last week when and appropriately so, Rachel kind of corrected me to say, hey, what the notebooks were doing, which is the notebooks we were discussing, which is essentially providing context during training without changing kind of the embeddings. In a technical sense, he was right in not calling that RAG, because from whatever little digging like you did, Steve, I also looked around, and it seems like RAG, technically the RAG paper originally referred to the tuning of the embeddings that go into so if you want to customize the pre-trained generative model, which is just the autoregressive part on your data, then there are like a couple of steps you can go through, and one is to get the embeddings of your own data generated, and that's the kind of the RAG part. But then what confused me was the paper that, or not even the paper, the notebook that Raquel pointed us to refers to the, just the providing the context when you ask the query, because all that that notebook did was, instead of using the DeBerta model, he uses the Llama 2 model and the Llama 2 70 billion model, which he brings in the innovation of doing layer by layer. But setting aside that part, he is just enabling using the context, providing the context, which all the open book notebooks are doing for each of the questions. So it's more like question, context, answer. And you, by doing that, and then you make the model better able to provide, as you prompt, the correct answer. But that technically, as Raquel was correctly said last week, when I was referring to it as RAG, and unfortunately, I think he corrected me, saying, hey, RAG would be where you kind of change the embeddings. In this case, we aren't changing the embeddings, right? Like, we're just providing context during the prompt in order to make the answer be better. So that's what I was, that kind of somewhat cleared up my understanding, but I was confused all over again, because this particular notebook that Raquel pointed to again refers to just modulating the prompt, which is question, context, answer, as, or context, question, answer, as also being RAG. So Raquel, any comment? I know you dropped off a little bit, but I was just saying, technically, it seems like what you said last week was correct, that RAG is when you, kind of modify the embeddings to be better suited to your own data. But this guy refers to RAG as just this process of providing context during a prompt. So any clarity around that? I wanted us to be clear on what we refer to as RAG versus not, because unfortunately, this particular notebook also refers to what, not changing the embedding, but even just providing context during a prompt as RAG.
Yeah, so from my understanding, the providing of context is done by using your prompt. So I said, finding the context is, from my understanding, the retrieval augmentation, because you're given the prompt, you're given the prompt in this case is the query or the question, and you have your 5 answers. And what you're doing with retrieval augmentation is you're saying, what if I take this and convert these into embeddings using a model XYZ, my Wikipedia articles have been converted to that same embedding space with that same model XYZ. Now find which embeddings are close to this, which you say, I don't know, using an L2 distance or whatever. And that is what is coming back as a context. So that is where the retrieval augmentation is happening. So now most of the notebooks, the way they're kind of panned out is, I think your data set already comes back with your question and answers, but you are already, if you're using a data set which already has the context, like if you're using like Chris Diot's one of his data sets, they already have the context already kind of attached to it. So that phase of doing the retrieval augmentation has already been done prior to this. And someone has provided you, okay, these are the contexts that are relevant to your prompts and your answers. So that's kind of my understanding of retrieval augmented generation, that RAG.
So you're saying that in this case, because the context is, using sentence transformers, they kind of create the context in the same embedding space and just measure the sentence transformer is mainly used to do this distance calculations, right, between the context and what you're retrieving,
Yes.
between the query and the
Yes.
relevant passage that you are retrieving. And so this is also appropriate to call this at retrieval augmented generation.
Right. So if you move ahead to the inference phase, right? In the inference phase, all you're provided is question and 5 answers. So what you're doing is you're taking that question, probably you're appending your answers to it too, converting it to an embedding space using a sentence transformer, XYZ, whichever model. Looking up on the Wikipedia articles that have been converted to the same embedding space and doing a distance match. That is the context that you're retrieving and saying, okay, given this question, given this context, given these 5 options, what do you think is my best answer?
Okay, then in this case, as Steve was saying, so what would fine-tuning as opposed to retrieval augmented generation, what would fine-tuning entail? In fact, that was the question that was in my head. So what would fine-tuning mean in the current context? How would you what is the goal and what would be different than what we are already doing?
Right. So again, like my understanding is that all your base models or foundation models are just like language models, right? They're just going to be generating your next token, and that's right, autoregressive in nature.
Right. Autoregressive pre-trained. That's it.
Right. Yeah. So now let us say, for example, GPT 3.5 or so, you do instruction fine-tuning on it. So what is happening is you provide them instruction, you provide that context, you can provide that a prompt, you can say these are my options. So you're kind of doing that instruction fine-tuning, and that's the way I was training my model. So when I was fine-tuning, I was saying I had this huge instruction which basically said, given the context below and the question below, look at the options and then answer this question to give me one of the following letters, A, B, C, D, E. And I fine-tuned it. And my
hang on, just
yeah.
sorry, Rekil, I had a question. So when you say that given the context, but you are then retrieving the context already based on what you said earlier, which is you're kind of taking the question combined with the answers and sending it to the sentence transformer to extract the relevant context. And then when you say you're fine tuning, you're providing that context and the question and the answer and prompting the model to give whatever please provide whatever modifications of the prompt that you want to do in order to get one answer or three answers or whatever. Correct?
Right. Yes, I think there is.
And are you using? Sorry, one more question. Are you using all of the like the 60,000 data points data set that Steve was referring to do this?
I'll come back to that question because I started with 10K, started with 1K, moved on to 10K, and I'll talk about some weird things that I got with my results.
Okay.
But before that, I think there are two models that are being used here, right? There is one for the retrieval stage, which is you can use like, I don't know, if you look at that notebook that I shared, I think he talks about there are actually much better embedding models than using the current embedding model, which is ranked at, I think, 35, whereas there is something with the same embedding space of 384 vectors still ranked at 6 or 12 or something like that. So that is that is one model that we're using for the retrieval stage. Now, the process of this is you first do retrieval.
Okay. I just shared that notebook that you're referring to on the screen.
Okay.
Go ahead, please.
So you first do retrieval. After you do retrieval, you can update your data frame, right? Your data frame, which had just question and 5 answers, you append this context column to it. Now you take this new data frame with the appended context and then pass that to your, at least that's what I'm fine tuning on, where I'm saying, given a task of, my task is given this context and this question followed by these 5 options, choose the most appropriate option, letter or whatever, something like that is what I'm using. So that is where, I think like the retrieval stage is already finished in that case. You've already retrieved and appended it your context in that case. So that's why I was saying, like in the inference case, now when you have just your question and your answers, multiple choice answers, you have to do retrieval again for that question appended with, I don't know, your answer or whichever strategy you use. Once that context is in there, then you pass that to Llama or GPT or whatever model you pass it to. And that should spit out the way you train it, a single letter, 3 letters, whatever should come back.
Okay, so the fine tuning that is being done is post retrieval, and the retrieval model, quote unquote, can be different because that will give you the size of the embedding. And like, for example, like you said, the embeddings are 384 for the ones that he has used, but you could create, I think, other models like he's referring to here, like the stable Beluga, Blackbird 2 or whatever, which have up to 1024 wide embeddings, right? And so you do that using the embedding model, which is best, and then go to fine tuning. So the fine tuning step, you use whatever, 60K, 10K, whatever you have, to still then train the Llama 2 model or customize. That's the fine tuning you're doing on your data, but not just the retrieval part, but the generator part. In fact, I think, I just attended a 1-hour lecture last week where they were talking about kind of end-to-end retrieval augmented generation. And this seems to be an example of that, right? Because they were talking about, and I'll post a link to that in chat, but they were talking about a retrieval phase kind of modification, which is what you're referring to by using some models, like a variety of models can be used for that. And then a generative phase fine tuning, which is what you're talking about as the next step, where you're actually tuning the autoregressive model to do a better job on the prompt by fine-tuning it on the specific data that you have.
So I think the technical term for that second part, I think that is what is called instruction fine-tuning, if I'm not wrong. Where basically like GPT 3.5 or any of them, they know what pretty much as a foundation model, they know stuff. You're really not teaching it something new in that sense, but what you're trying to tell it is understand my problem and generate the output the way I want it to. So you're kind of guiding it and moving it towards the way you would like your answer. So that's pretty much, yeah, what you're trying to do with the instruction fine-tuning stage. And in our example, it's more like, oh, okay, fine. Just given the question, you can find out what the answers are. But how about you look into the context too? So then it kind of understands, okay, context, question, these are my options, and then I should generate just a letter or 3 letters. So that is the, yeah. And so when you talk about fine tuning, in theory, you should be actually fine tuning your embedding models too, because the embedding models have not been trained specifically for your data set. So the reason why I kind of pushed this for, I think I was planning to do it maybe next week was, I think Chris's notebook has somewhere he mentions where he says he created embeddings for Wikipedia. He created embeddings for the 200 questions in the validation set. And then the TSNE, and he saw that most of it overlapped. So since the data set, he said, had part of it STEM and part of it was not STEM, because of the overlap, it was a very reasonable assumption to kind of go ahead with it. And he continuously has been pushing that you're not trying to teach it science, you've been trying to teach how you should look into context and answer the questions. So otherwise, you should be fine-tuning your embedding model too.
So this one is akin to freezing your embeddings and then just fine-tuning the rest. In a way, correct?
Which
because
one
you're
is
not
that,
fine-tuning the embedding.
Right
what you're doing where you are not.
Yes. Right now, we are not doing that. Right now, you're
Right.
just saying
so
that
it's
this
like
model,
freezing your embedding.
yeah, freezing your weights rather, right? Not embeddings. You're freezing your weights. You're getting the embeddings as the output. Embeddings is what is your 384 vector.
Right, but you're not allowing those embeddings to be changed. Is my point.
Yeah, correct. Right now, yes.
When you do this part.
You're not. Yeah. You're saying this is your final model, and then you're just using that. Now, my problem with using 1,000 or 10,000 data points, I get exactly the same map one accuracy. So I don't know if I'm doing something wrong there, or I still haven't figured out if there's a nasty bug there. That was
when you say when you say you're with the 10K and you're validating with the 200, or
yes, I'm currently just using. I split it up into what Steve pointed at, that 50K and 10K split. So I was using only like 1K and 10K from that 59K stuff. But yeah, when I was validating, I just finished this yesterday, so I thought let me validate on the 200 and see how it goes. And yeah, it was pretty bad.
I see, because I was thinking that maybe the 200 is too small. That might be
for sure.
The reason that you may be.
Absolutely, yeah. My only understanding was
real.
I think my only point was that if I'm training on 1K versus 10K, I should at least improve my results. I'm not using that as a like a metric to kind of move ahead, but I was just assuming that it should train better. Or maybe what I should have done was pumped up from my 7B to a 13B model and then tried. So yeah, but yeah, I got test time augmentation running for just swapping out the options, only to realize there are like, if I'm not wrong, there are like 120 combinations, right, that we can do since there are 5 options.
Right. So by test time augmentation, you're talking about changing the order in which you present the sequence of choices and see whether the model gets better because it sees maybe the correct answer third sometimes and the correct answer the first sometimes, right?
Right. Yes, exactly. And since the language model is taking in the context, everything, it takes the whole thing as one chunk, right? So my thing was like question and answer a little too far. I don't know how about attention is working. So that's why I was thinking, especially to swap E and A was one I did, and then I swapped D and P. So yeah, kind of flipped them around like that. So what it was not able to see, I mean, not able to see, but yeah, later it what it was seeing. But yeah, so test time augmentation did give me a little improvement of results.
I see. Yeah, I was wondering what your results there. So
Yeah,
you're
that
saying you saw a
actually
little
bumped it
better
up.
results.
Yeah, that was surely an improvement. Oh, and then the questions are super hard. Like I was trying exactly the same question and I threw it into GPT 3.5 or GPT 4 itself. And it actually gave me the same answer as what Llama 2 fine-tuned was giving me. So yeah, I don't know.
Yeah, but there, no, there you saw what we covered it a little bit. I was surprised by this, by the fact that if you saw Jeremy's playing around, he pointed out that actually a couple of the answers are actually wrong
Oh, I see.
by
Okay.
GPT 3.5. Okay, so in fact, the data set has it incorrect because remember that they used GPT 3.5 or 4, I forget which, to generate this question answer data set, right? And the answer generated by GPT 3.5 is itself wrong. In fact, in one case, he shows a couple of examples where it actually is the wrong answer. And if you look at the thing in detail, the correct answer is subtly different. He goes through one example, and then at least points to another example for sure. So there may be more examples, which itself, I was saying very early on, is a very interesting question of, is the effort to just, obviously your score will be better if your model is exactly wrong, like GPT 3.5 is wrong. But are you after the correct answer or are you after mimicking the model?
Right. Yeah, makes sense. Yeah, that's a good point. Yeah, I missed that completely. Okay.
Yeah. So if you look into that very early on, I was like, wow, that's it's like a meta problem to think about, right? Like,
yeah, exactly. Yeah. Yeah, I totally get that. Yeah, that's an interesting one. Oh, and
anyway,
the
about
other,
to say something?
What model was it you were fine tuning, Rekal? Were you fine tuning Llama to chat version or the base version?
The base version.
All right. Yeah, because like as I say, like in all of the sort of tutorials I saw, like it showed you how to use like PEF to fine tune it and stuff, and how to get your final model. But like none of them give examples of
when I get back
what
home,
the
I'll share
output
a
was.
notebook. That notebook trains the base model to generate code.
Right. Does it end up? A lot of them though, they seem to, with their final model, like once they combine the PEF thing with the base model, then they like push it up onto the Hugging Face hub. So, rather than actually sort of using their model themselves to show what comes out of it. So I hadn't found any tutorials that actually showed you what would come out. We also using as well, like I saw like a lot of it, like all of the prompts, how they sort of put it together with instructions and things. Did you do that, or did you just have question?
No, I saw a prompt. Basically, I'll share this once I get back home. The notebook where he trains Llama 2 base for code generation. So he had a bunch of obviously much lesser prompts like than ours, because his was more like, okay, given the task, you're given the task to generate code from the following statement, and then it says that, okay, this is the task and this is my output, and that's how they train it. And he does give an example, but I mean, it's a very simple example, like how do you print out like the first and last element of the list or print the factorial and stuff like that. Probably Llama 2 by itself, probably would have just done it without the fine tuning. But that was the notebook I started with. So that's what I used. And yeah, I just kind of added more things to the prompt and used that for the fine tuning aspect. But yeah, like I'm pretty sure maybe there is something weird because I still can't digest the fact that 10K versus 1K data set are giving me a bang on the exact same results. So yeah, that's where
Now,
my fine
were
tuning
you doing
experiments kind of I have reached right now.
were you doing top 1 only or top 3 or?
Right now, I was just doing top 1. I didn't bother doing top 3. I was just seeing, yeah, like I said, I was just trying to see 1K to 10K is improving because then obviously I can just trigger off a model with maybe, I don't know, 20, 30, 40K and it can do that over some time. But yeah, that did not pan out the way I was thinking. So yeah, I haven't taken that off. Actually,
I posted some. Go ahead.
No, so I was just going to say, like, looking at the options for the MCQ, I was thinking of trying something like, can you tell me what the difference between each of these 5 statements are? And then kind of use that as my context and then try to push that to train a model. I haven't gotten to that, but I was just experimenting with that and quick results gave me something
and
promising.
combine it with the context already that you're providing. Is that the idea?
Yeah,
or just that?
No, not just that, because some things are really tricky. If you look at the answers, some of them are very explicit in terms of, like I was using that Mond example. So the statement reads, Mond is blah, 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 blah. So then I think the network can kind of understand what is going on. But some of the answers are just like 1-word answers. So I really can't expect it to understand. Like if I tell what is the difference between these 5 answers, then I don't think it's going to work there. So I think I was planning to kind of prepend this to the context rather than append it to the context and give that a shot. But yeah, that was something that I was just thinking. I think there was someone else or something where I was reading where they were asking each of the 5 options to evaluate that and say whether it's true or false, and then kind of proceed
yes,
from
I
there.
saw that too.
Yeah.
Yes.
So
as a step in the prompt rather than as a step in the prompt.
Yes. So yeah, not sure.
Yeah, no, I think that's, those things are similar to some of the prompt engineering, that 1 hour or whatever course that deep learning.ai Andrew taught with a lady from OpenAI. And in that they do, and Jeremy has also pointed out somewhere in his, tweets or whatever, that if you tell the model to, even when doing math and other things, if you tell it, be careful proceeding steps, first do this. So exactly, then the model gets better. So in fact, one of the things, along the lines you're thinking of maybe is to say, first determine the truth or falsehood of each of these answers with respect to the question. Once you have determined that, then proceed to choose the best answer. Might even do what you're trying to do with adding to the context, right?
Right. Yeah. Something like that. Yeah, for sure.
Which is prompt engineering inserted into the stuff. Like use the context, but then again, kind of tell it to proceed step by step to determine the truth of each or falsehood of each of the 5 answers. Then pick among those which is determined to be true and see whether it gets, which is the best of the choices, and see whether that gets you any better.
Yeah, something like that. Yeah, exactly. Yeah.
Yeah, but the other thing I was thinking of as we were doing this was, especially the notebook that you read, that you pointed to last week. One of the things I've been kind of thinking about this. I don't know that it matters in terms of the competition, but see, the goal of the competition, at least initially as stated, was, hey, can we get a smaller model to do as good or better than the gigantic LLMs, to give when the gigantic LLM provides some data or does a task, can we use a smaller model? And the purpose behind that question was, this way then if we can kind of generate more data or train those models better, or actually more importantly, come up with means to validate those models, which is becoming a challenge, right? Because some of the metrics are struggling as to how to evaluate the model. And I was thinking, if we continue to proceed to use 70 billion and eventually proceed to using, we can't do this in the competition because of the Kaggle restrictions, but in fact, if we blow up that dimension, then we are kind of, our score might get better, but we are kind of defeating the purpose of the competition.
Right. Yeah, makes sense.
Right, because the competition purpose was, hey, how well can I? So I'm kind of curious. Much like in a couple of previous competitions we had, they were also giving efficiency awards, right? So
exactly.
In some sense, that would have been that would have been an interesting thing to add on to this.
Correct.
Which model is most efficient in doing it, not just in getting the best score, because you can use GPT-4 to do GPT 3.5 or whatever, but that kind of defeats the macro goal that is being set.
Yeah.
Although I think part of it was, like they're sort of saying GPT 3.5 can't run on Kaggle or typical sort of home GPUs. And so they were trying to get people to be able to get the same performance as GPT 3.5, but just running on basic Kaggle hardware, which, as you said,
or
squeezing that 70 billion parameter model in by using smart techniques and running it a layer at a time. So that's pretty impressive.
Yeah, that was pretty. Yeah, that's what was. Yeah, that blew my mind. But in terms of the competition, I agree.
No, but even that is an innovation that wouldn't have come around if it weren't we are stuck with this hardware. Now what do we do, right?
Right, exactly, yeah, and there are a lot of optimizations there, right? The key value caching and using it the layer by layer, and all that kind of stuff is smart innovation. But in terms of the competition, probably, I agree.
Yeah, no, but smart, not just in this context. I'm sure those will get used in even larger context. They would still be applicable, right? So, when hardware is a limit,
I'm saying
you can still use those techniques.
Right, you can move those ideas over right now also, right? There is a limit of 9 hours, so maybe you have enough number of models to ensemble. You still can use key value caching, and you still have such long context, because I'm talking of the whole context, right? Not just the context of the question. You have the question, you have the context, you have all the answers. It's a pretty long paragraph over there that you have. So if you can speed that process up, that means you can push a lot more models through compute answers. So all that. For me, I think my goal is I have used embedding spaces with the GPT 3.5 with vector databases to do searches. So it was very interesting to kind of use that that is 1,500 something vector length. This is just 300. So I was just curious to kind of use that approach here. LoRa training is extremely interesting and I think very useful. And putting it all together with this, a Llama V2 fine-tuning with LoRa. So those are my 3 things that I want to get away from this competition from.
Yeah, I'm way behind in terms of getting on those. I had a question though on that topic since you mentioned. One of the things that I've been seeing is people, and maybe I just need to think harder. So I'm just trying to get easier answers for somebody who has thought through this. So one of the things they talk about, is the QLoRa, right? You can quantize the LoRa models and thereby get even smaller models. But then there is also this comment, which, as I said, I haven't thought about too hard, as to when you use the models, you have to dequantize. And am I understanding right, or is it in the production that you have to dequantize, and if so, why? Why can't you just deploy, or am I not reading what they're saying precisely?
I may not be
I've read.
Right. I think, yeah, I may not be 100% correct on this, but yeah, my understanding is the same. And I think that's just the way the CPU or the GPU works. So like even when we quantize models to deploy on an iPhone, like you deploy, it's smaller. So let's say when you download the app, instead of downloading 30 megabytes, you're downloading, if I've quantized it from 32 to 16, you download 15, so it's faster. But at the end of the day, when you're trying to multiply, you have to bump that up. So that is correct. The why aspect of it, from my general understanding, I don't know, probably, I think Mayank maybe, or Steve, or I don't know, someone else probably knows better on this. It's just that, I don't know, like, I think that's the necessity for the GPU, for it to do the multiplications part of it. I'm not 100% sure though. So, yeah.
Yeah, because the hardware is the hardware, right? I mean, there isn't, yeah, because if you quantize it, you're just saying, okay, I am reducing the numbers,
exactly,
meaning reducing the range or whatever,
range, yeah.
So my accuracy wouldn't be as much. And then, like you said, you know, you can ship it and stuff. But then, if you know, I don't quite get why you. I mean, I can just simply understand it as, oh, well, I mean, you just want the original accuracy with which you have done stuff, and therefore dequantize, because then you're getting back all of the stuff. So at that point, quantization is simply compression.
No. If you dequantize, you don't get back the stuff, right? Because you've lost range. It's kind of it's not a lossless compression. It is a lossy compression. Like what?
Right. So then why would you decompress is the part that I don't get.
So that's what I'm saying. I think the decompression is a necessity on the hardware side of things to do the multiplication and to do the addition and that kind of stuff. And yeah, don't quote me on this. I'm not 100% sure, but that's what. So, like, for example, if we deploy a 15 MB model or the non-quantized 30 MB, the 30 MB takes longer, takes up more space versus the 15 MB. But when we run it, it finally takes the same amount of time on the phone. And I don't know if there are other things that Apple does under the hood that is creating issues, but at least this was my takeaway from that yeah, it is needed. So it saves on memory. It saves on memory even while loading and obviously while training the model, right? Because you have RAM limitations and yeah, you have. So you want to squeeze in how much ever you can and put it into the model. So that is kind of the benefit.
Okay. So Steve, you're saying that basically you haven't seen examples of where this kind of fine-tuning with RAG actually demonstrates better results on some examples. Is that what you were mentioning?
Well, as I was sort of saying was, in the tutorials, you'd have thought that you would start your tutorial by saying, like, here's like a base llama model, and if you ask this question, here's the response you'll get. If you fine tune it, here's the response you'll get after you've fine tuned. And yeah, so like none of the ones I saw actually sort of showed you the benefit of fine tuning. Like these are all Medium articles. I don't mean Kaggle notebooks. In the Kaggle one, yeah, like somebody's got like a llama inference thing with a fine-tuned model, and yeah, like certainly with it, yeah, like it would give me about a 0.7 score. just with their fine-tuned model, but I think they fine-tuned it without any context. They were just asking the question and giving it the 5 answers.
Yeah, actually, the Colab notebook that I pointed to, I posted in chat, and I'll put it up on Slack too, and a few other pointers related to that. This was like a 1-hour, AI makerspace lecture that I attended just 2-3 days back. That one, he actually runs the base LLM and then runs the RAG augmented end-to-end model and shows you that it's not a scoring thing, but it actually shows you how the result is much better by putting the 2 paragraphs that the models return, the base LLM model and then the RAG end-to-end fine-tuned model, and shows that in one case it's spitting out generic, not really relevant to the question and type of answer, and in the other one it's very specific and it gets much better. So that I thought was kind of instructive to show
right, so
how do end-to-end.
Yeah, so I think that is what the key with the fine-tuning is, right? So if you use a base Llama model and put your question and your 5 options, you'll probably get back a long generated text. And somewhere in there must be the answer, which will say option A is right or option B is right. Now, if you want to kind of deploy this or use that in a Kaggle situation, you just want A, B, C, D, E back, right? So that is, again, part of the fine-tuning that you're teaching the model to do. Yeah, I think like instruction fine-tuning is what the terminology is. If you kind of look that up, it does a better job than me trying to explain what I'm trying to do right now.
Yeah. But it seems like you could potentially do one or the other, and the original RAG probably was focused on the embedding portion of it and not so much the generative part of it, at least based on what this end-to-end RAG guys seem to be saying. But the enhancement, or there's apparently a
so can you explain more about
end-to-end? That's where there, as I understood it, and I posted the video link. I'll also post eventually the link to the paper, the original RAG paper and the E2E RAG paper and stuff. But as I understand it, what they were talking about end-to-end RAG is in a single. So this Colab notebook I posted actually does both in a single notebook, but which is tweak the embedding and then do the generative, which is what you're referring to as the instruction fine-tuning.
Okay, so basically, so RAG here is basically just using the Llama 2 model or whatever LLM you're using to generate the embedding space, and rather fine-tune that to get a better embedding space to represent your documents, right?
Right.
Okay.
Right. And then there is the instruction fine-tuning, or these guys refer to it as fine-tuning the generative part. So they kind of think of it as one is the retrieval part and the other is the generative part. And that makes sense too, right? Like the retrieval part is where you tweak the embedding. And the generative part, what you are calling the instruction fine-tuning part, is to tell the autoregressive model to do the generation better tuned to what you actually want, like the 5 letters or whatever else that you would want the model, not just autoregressive, but fine-tuned to do what you are telling it to do. And you can call it instruction. What were you calling it? Instruction fine-tuning, right? And they call it generative fine-tuning. So I'll post the link to that, because at least that gave me a little bit better conceptual understanding of the separation of these two and the combination of these two. I haven't read the papers themselves. I just listened to the video and attended that 1 hour session, but I thought that was an interesting, and I posted the GitHub thing of link and stuff, but I'll post more about that because that's, I think, very relevant to what we're talking about here.
Right. So the retrieval thing has been, pretty big, like BM25 or any of those algorithms were the ones which were traditionally being used. Then with the transformer architecture and those kind of things, you pass this through this model, and that kind of gives you a much better representation in terms of these embeddings. And then these embeddings places, you train it in such a way that they end up being close to each other. So the retrieval thing, I think, like in the chatbots and those kind of things, or I don't know if you have a company where people ask you questions about your company, so you can kind of load all your docs into that and then store that in a database. And then when you get a new question, you kind of query, find the embeddings for that, look up the embeddings for your relevant docs, which are the closest, and then you fuse that question, the documents that have been retrieved, and then you pass that off to the LLM to kind of answer your question.
This whole
right
vector database or whatever the
right.
fine cone guy is trying to
right
part covered, right? Like being passed about matching, and what we are using sentence transformer for in this case, right? In our case, we are kind of using the sentence transformer to do that piece.
Right, exactly.
Convert it to sentence and then match it using whatever cosine distance or some other L2 distance or whatever metric. Yeah.
Yep. So yeah.
All right. So Emily, any able to submit or get on the leaderboard?
Yeah. There was a previous notebook that had the highest score, and one notebook came out today, and that's the 86.2 with only 270 articles. So I'm trying that. That's fine. And the previous notebook that I tried had the 84%, so 0.84. That was the score that I jumped onto the leaderboard with.
How about you, Emily? Any submissions?
I'm still kind of early on. I forked part 2 of Chris Diat's notebook and played around with it a little, but I think I'm still struggling with the basic mechanics of Kaggle. Yeah.
I see. Yeah, there are some text. There are some help notebooks that talk about. Unfortunately, they keep changing the interface and stuff, which even for guys who have been on it for a while or people who have been on it for a while, it still confuses us. So don't feel that that's unique to you. They still keep moving things around or the behavior changes and stuff. So, but I think there are some, here's how you submit and here's how you run the notebooks and stuff like that, that you can look into if you're having kind of getting on board trouble. But as Steve said, you could probably just click, copy, run. And by the way, running, there's all these things of you don't have to run interactively. You can just submit and shut down the interactive run. And then once it's done, go to the output tab of your notebook and then click submit. And that should get you on the leaderboard.
Yeah. I don't know. Maybe I need to switch browsers or something. In this competition, so when you submit, you click on the submission CSV and submit it directly. You're able to do that.
Yes, once you get submit. Let me see whether I can just show you stuff based on.
Yeah, so if you copy somebody's notebook and then you press, you got to save your own copy. So if you copy one, like you do copy and edit, and then you
Yeah.
save it, if you save it in the standard way, it'll generate the submission.csv file.
Yeah.
And then, yeah, like that'll be in the output section of your notebook. So if you go to
Yeah.
that, then just click on it, a button will appear for submit.
Yeah. Yeah. I submitted, but then I get dashes. It doesn't evaluate the model or the submission.
Whereabouts do you mean dashes? Sorry.
In the score, like it shows up that I've submitted, but I have no values for the score.
Does
How
it
long
say
ago did
something's
you?
gone wrong?
Yeah. Sorry.
I'm sorry, I
Yeah.
was just asking, how long ago did you submit it?
Oh, not that long ago. Maybe like an hour ago or so.
Oh,
All right. Yeah. Some of the models there take about 3 or 4 hours to run.
Ah, okay. It's a queue.
Is it like,
Yeah,
if it's
yeah.
still running, it'll still have the spinner on it?
No, there's no spinner.
No.
Just dashes.
Uh,
Let's see. Yeah, so like,
Yeah, dashes signify that you have run your model and it's waiting for the scoring to take place. So the scoring, if you go back to your left and hand side panel, the the leftmost panel, on the bottom there will be one active event. If you click that, then there will be a pop-up from there that says one scoring.
yeah, so I've like, I'm not, I didn't, sorry, I'm sorry, I didn't follow entirely. I hit this, I went through this.
I've never used it that way before. You see in
Oh.
your notebook,
Yeah.
This is a notebook you want to submit. You know, the top and the main
Yeah, yeah.
yeah, just go up a wee bit. Just go up
Oh.
slightly. Yeah. Oh, yeah. So this is the notebook. If you go to the very top a minute,
Okay.
right to the very top. Yeah. So actually, yeah. So like this must have saved. So if you can go see the main menu on the left hand side, the icons,
Yeah.
the less than and greater than one, which is the code one.
Oh,
Oh no,
sorry.
down a bit, down a bit, down to that one.
This,
Yeah. If you click on that one a sec.
yeah.
Yeah, you're okay to leave there. So yeah,
Okay.
just click OK. Yeah, and then click on your work.
Okay.
So these are all the models that you've saved. So is this the one you want to submit, the fork of how to train part 2?
This one, yeah.
Yeah, so if you click on the title there of it,
Okay.
so this is the saved version, right? You can see now you've got like the different options here. You've got like notebook input and output. Just below
Yes.
the title of the thing.
Under
Yeah, so if you click on output,
I
yeah,
see.
so this is a submission
And
file,
then submit.
and then yeah, if you
Okay.
click on that submit, yeah, so you
Yes.
just click submit there. You don't need a message
Okay.
for.
Thank you.
This should take you to your submissions. Oh, yeah, so you do actually. So now you've got it running twice. It was actually running. So this
Oh,
is your main
okay.
submission. So yeah, you got the spinner,
I
and
see.
as
I just wasn't
Raquel
looking in the.
said, it could take
Okay.
several hours for this to finish.
I see. Okay, thank you. I'm sorry for
Right.
such a
Can you
question.
can you go back to the notebook that you were sharing, Emily?
Yeah.
One more back, I think. Oh, yeah, the notebook. This is the saved version. Can you go one more? Is there like you were sharing one which had?
It doesn't. Let me go back here. I can get to it here.
Yeah, can you
Which
open that if you don't?
Sure.
Which? Oh yeah, I think I don't know. Maybe so when I'm working on the notebook, I saw that option for you show up, but then I don't know. On the right-hand side where you see table of contents, below that you basically will see your GPUs that you can use, and there's a submit button. There's a submit button right there.
Yeah, that's what I
So-
tried. I guess it did submit. I guess I was just didn't give it long enough.
Yeah,
Is
okay.
that what
So
it
that
sounds?
submission works too. Yeah, probably. It's just running.
Okay. And I guess that just depends on the specific competition requirements. Like they'll automatically look for the submission CSV. Is that a fair assumption? Like depending on, they'll tell you what they're looking for in the competition description.
Right.
It's
Mhm.
it is all CSV format on that. So yeah, so like in this case here, although you've got like a submission.cs file that your notebook has generated, it's only like a dummy one really. So it's,
Okay.
when you click submit on it, it actually goes off and it runs your notebook again. So like
Yeah,
that's why
yeah.
it takes a long time, because your submission file only contains the 200 dummy entries. When it actually runs it, it'll run it on all the public leaderboard data, and it probably runs it on the private leaderboard data as well. So as they can, at the end of the competition, they can just instantly show which notebooks won.
That makes sense. Okay.
And like you said, also in this case, it's a notebook competition. That means that, or I forget whether that's what they call it, Steve, if you correct me, something where your notebook is actually done. There are some competitions in which the data is just checked, and that would be where when you hit submit on the, and there again they would say, and typically it would be again called submission, or they'll give the what the name of the file should be and format and all that. And if you submit that, then in those competitions, they don't rerun the notebook, they just check the data. And there are both, but more often than not, you'd have notebook competitions in which, as Steve just described, when you hit the submission button and on submission.csv, it actually reruns the notebook on the hidden data. And eventually, when they rank it, they take and run the notebook on the private hidden data that they retain in order to score.
Right.
That's why you see eventually at the end of the competition, the shake-up that people are concerned about, which is, when all of the data is used, the results may be quite different sometimes than what your score was on a limited subset of the data.
Sure. If you like, particularly if you overfit on the on the public test. Okay. Okay. Thanks. Appreciate it.
Okay. Anything else? Michael, you were about to say something?
I just had a question for Mayank, like which notebook was he talking about, and has he gone through that? Have you gone through that, Mayank? Is there like anything different from what we have spoken, something to look at? I'm just curious.
This 86.2 with only 270K articles. No, it's the same stuff that we have discussed previously. He's extending it to
More data.
270K STEM articles. Yes,
Oh,
more
okay,
data.
okay. Oh, wow, that must be
I think
okay. Well,
the difference in it, and he rather than using like Debo, he's using, so he uses a different model on it. He says by using like long form, or I think he gets longer context strings or something. I only looked at it briefly. I only stole that one about half an hour ago, so I haven't looked at it fully yet.
Yes, we
Cool, okay.
use long form for large models, and the longer prefix context that he gives to the GPU memory.
He uses long former instead of sentence. transformer. Is that
Instead of
looked at it at
D,
all.
but a V3. Yeah.
Okay, cool. Awesome. We'll check that out then. Let's see.
Good deal. Hey, if there's nothing else, one more week, and we're getting close to the end of the competition. See you all next week.
All right.
Okay,
See you
cool.
guys.
See
Thank you
you
for joining.
later.
Thank you.
Take care.
See ya.